Okay, so welcome back. Now we're going to do another example where we have this series here. Okay, now we're going to use the ratio test and then we'll see what we get and then decide how to go attack this and decide how we're going to figure out what the radius of convergence is or the interval of convergence. Okay, so first thing we're going to do is set up the limit, right? And so this is going to be the absolute value of x minus 2 to the n plus 1 over n plus 1 to the 3 to the n plus 1, right? Divided by x minus 2 to the n divided by n plus 1 and 3 to the n. So we got the absolute value of that. Okay? So now I'm going to write this as a product. So I'm going to write this a little smaller to make some more room. Oops, not one. Okay? So now I'm going to write this as the product of the reciprocal, so I'm going to multiply by the reciprocal. So this is going to be the absolute value, and this is going to give me x minus 2 to the n plus 1 over n plus 2 times 3 to the n plus 1 times n plus 1 times 3 to the n over x minus 2 to the n. Okay, so now, see what cancels here. Okay, well, we've got 3n plus 1 and we've got 3 to the n. So these are going to cancel with these. So we're going to end up with a 3 on the bottom. We got n minus 2 to the n and x minus 2 to the n and x minus 2 to the n plus 1. So all of these are going to cancel with those. So we end up with x minus 2 on the top. Okay, now, what do we have left over? Let's keep going. So this is going to be the limit as n approaches infinity of the absolute value of what? We get x minus 2 times n plus 1 over 3 times n plus 2. Okay, so now, what do we do with that? Well, let's pull this out. Write this as the absolute value of x minus 2 times the limit as n approaches infinity of the absolute value of n plus 1 over 3 times n plus 2. Or in other words, we could just distribute. There's a couple of different ways you can do this one. So let's do 3n plus 6. Right? Well, as n goes to infinity, this is just going to go to 1/3. Right? So this is going to end up being the absolute value of x minus 2 over 3. Okay, great. Now, when is this thing convergent then? Well, remember, using the ratio test, this will tell us that the series is convergent if the value of the limit is less than 1. Okay, so we just need to find out when is this thing less than 1? So now we got to set up our inequality. So x minus 2, the absolute value of x minus 2 over 3 is less than 1. Or excuse me, less than 1, not 3. Okay, less than 1. So now that means we're going to multiply both sides by 3, which is then equivalent to what? That the absolute value of x minus 2 is less than 3. That, of course, this is equivalent to saying what? That x, let me write it here. So that means that x minus 2 is less than 3, or what? Greater than negative 3. Right? Which tells us if we add 2 to both sides, then that means that x is less than 5 and greater than negative 1. Okay, so now we know that now here's the ratio tells us where it converges absolutely. So we know that this converges absolutely on the interval from negative 1 to 5. Okay, now here's the thing. At negative 1 and at negative 5, or excuse me, I'm sorry, at negative 1 and at 5, this ratio test is inconclusive because it equals 1. Okay, remember the ratio test and the root test are inconclusive if the limit equals 1. Okay, so what we're going to have to do is we're going to have to test the endpoints individually and see what kind of series we get, and then figure out whether those series are convergent or divergent to get our final answer. But so far, we know that it's convergent within this interval. Okay, so now, let's plug in negative 1 and see what we get. Okay, if we stick in negative 1, if x equals negative 1, what happens here? This becomes what? Well, if I stick in negative 1, this is going to give me three to the n, right? Negative 3 to the n over 3 to the n times n plus 1. Ah, look at that. This just ends up giving me what? Negative 1 to the nth power. And this is actually, again, if I started at 1, right, this is the same as n equals 1 to infinity of negative 1 to the nth power, or actually n plus 1, no, n minus 1. N minus 1, and this would be over n. Is that right? Is that what yes, that's right. Yeah, that's right. So if this changes to 1, this would be minus 1, this will be, yes. Okay, so guess what? This is the alternating harmonic series, which is convergent. Okay, so at x equals 1, it's convergent. So now I can add equal sign down here. Now let's do x equal to 5. Okay, so what happens at x equals 5? Well, when this is 5, I get positive 3. So I get positive 3 to the n over 3 to the n times n plus 1. Well, guess what? This is going to give me the harmonic series. So this is just going to become 1. So this is just going to be 1 over n. And so this is the harmonic series, which is divergent. And so now we know what our radius of convergence is. So the the interval of convergence, is -1 to 5, like so. And what is r? Well, what's the distance between these two? So another way to look at this is it's the half width of the interval. Well, the interval goes from 5 to -1, so the width of this is 6, the half width is 3, so r is equal to 3. So the radius of convergence is 3. And that's it. Have a great day.